and Schneider and a bunch of adjuncts that work for us. And there's also a lot of activity in the computer science department. There are groups there working on IR. There's Grace Hu Yang, Nazli Goharian, people working on machine learning like Mark Malouf, Ophir Frieder, who's worked a lot on text as well. There's a bunch of people. It's a pretty lively program. And then also collaborations with other departments, including language departments, including other projects on computational social linguistics, data sets, big data initiative there, Lisa Singh, for example. That's a very brief, I think we should probably continue this offline because, yeah.
We've got several other faculty showing up.
Okay, that's fine. All right, so hi, thanks for having me here. It's a pleasure to be here. I want to talk about discourse today, but I also want to talk about feature-rich models. And what I mean by that is an interest as a corpus linguist in annotations and in analyzing data and in using those analyses to do interesting things. And based on some conversations that I've had with some of the students here this morning, I wanted to ask, how many of you are using RNNs to do something? How many of those people are using word embeddings with RNNs? Basically the same group. How many of you are using character embeddings? Slightly smaller group. How many of you are using other categorical annotations on top of those that you're feeding to your networks? So, encouragingly a couple, but remarkably less than half, right? So more than half of you who are using RNNs are fine just throwing text at them, basically. And I hope I'll be able to convince some of you by the end of this talk that maybe you can reconsider that, or maybe you should be reconsidering that, depending on what you want to do. Okay, so what I'm going to be talking about. I'll start by explaining what I mean by discourse relations in general, and then more particularly talk about the framework that I work within, which is Rhetorical Structure Theory, or RST. Then I'll talk a little bit about data sets, particularly the RST Discourse Tree Bank and one that we build at Georgetown called GUM. And then I'll move on to the main topic of this talk, which is signaling. So I'll talk about ways in which both humans and machines know that a certain discourse relation is in evidence in a certain text, right? And I'll present a corpus that's been used to study both explicit ways of signaling these relations and implicit ones. It's called the RST Signaling Corpus. And then I'll present a text-based RNN model to detect those signals, which does all right, as you might expect. And then I'll move on to talking about what happens when you try to add features to that model and when you try to teach it things that aren't in the text. And my focus in this is trying to understand what kind of information you'll be missing if you only look at the text and what kind of information is present in other parts of the data. Okay, so discourse relations are kind of hidden categories that people have assumed exist in language because people are able to infer certain things pretty reliably. So for example, if I say John pushed Mary and then I say she fell, most people infer that this is a cause relation. Mary fell because John pushed her. And of course, there's also a kind of temporal iconicity to it because I say the one thing and then the other thing and probably one thing happened and then the other did. But if you look at 1b up there, you can also phrase it the other way around. Mary fell, John pushed her. In some interpretations, that's even a stronger indication that this was a cause relation, actually. And there's a lot going on there. There's the fact that there's a pronoun used here and not here, and there's all sorts of interesting things going on there. But I think people will agree that even though it's not explicitly formulated, most people would perceive this to be a cause relation, and you can argue how much of that is information about language and how much of that is information about general cognition. You'll also notice that I put some colorful matched brackets around that. So this is blue on the outside and white on the inside for the cause. This is because there's good reason to assume that discourse relations of this kind are hierarchical. So for example, if you look at 2, they left the lights on, so Ellie got mad. That is pretty similar in terms of having a possible causal interpretation. You'd say because they left the lights on, therefore Ellie got mad. But then I say that's totally unreasonable. And when I say that, we might think that that's an evaluation. I'm claiming of this thing that it's unreasonable. But it applies to both of the things on the inside, right? It's not just unreasonable that Ellie got mad. It's unreasonable that she got mad because they left the lights on, right? So there's a hierarchy. Okay, so the green bracketed part is being commented on by this evaluation here, and they all belong together. Okay? So that's kind of the basic idea. But it raises a lot of questions. I think one of the most interesting questions, which I won't be talking about today at all, is what is the inventory of relations? Right? So what kind of relations are there? Are they the same across languages? Very interesting question whether languages either have unique relations that aren't exhibited in all languages, or whether the proportions are very different. And this goes back to language and culture and all sorts of cognitive hypotheses about what you tend to say about things, right? Another question that I'll deal with a lot more extensively today is how these relations are marked. Right? So supposing that you assume that there's a certain relation, say contrast. I've expressed a certain contrast between two statements. Am I marking it explicitly, such as with a word like although? These words are sometimes called discourse markers. Or maybe even multi-word expressions like on the other hand, which is basically doing a very similar job. But there are also things that are sometimes called implicit signals. So there might be genre conventions about how you express certain meanings in a certain, if you are reading a newspaper article and there's a date line, you know what that means. Right? Not in every genre could you just pop a date into it and it would mean this is the date at which I composed this piece of text. You know that implicit relation because you know how newspaper articles work. Right? Or just things like coreferent mentions. If you use a pronoun to refer back to something, that's a means of cohesion. It means this is about the same thing. So that might be considered an implicit signal of some sort.
I think I know where you will go with doing the discourse annotation. It might be similar to what we did in the Mann discourse.
That's one of them.
If you just go back to your example for a second, I'm wondering whether you touch upon this, namely that that's totally unreasonable, you said, applies to the whole construct of getting mad because of like sound. But
right.
Also a larger discourse context where I was talking about how people are wasting energy and how the planet is warming up, then the inference might be that what is unreasonable is leaving the lights on, not really getting mad.
Totally possible.
So when you say implicit, I'm trying to think about implicit just in the sense of neighboring sentences or implicit in the sense of creating.
So first of all, there's ambiguity, and you could get all sorts of readings where that is not the relation or that is not the hierarchy. And certainly you can get very long distance dependencies between things. I think one of the classic ones is restatement, which is often taken to be a discourse relation. I can restate something that I said earlier, just repeat it, and I can do that very late. And still you'd say, that goes back to what I said over there, right? Or you could summarize things. And that's why I think, and then you're suddenly referring to the entire text. So certainly these things happen, and they're interesting to study. But in order to be able to study any of these things, you need an annotated data set because you want to come at it without prejudice. You want to say, I'll look at a bunch of text and I'll annotate everything. Then I have both positive evidence and negative evidence, right? If you just look at cause sentences by looking for the word because, then you've biased your data. What you ideally want to do is take natural data and just categorize the relations and then say, okay, it turns out that the way that people express cause is like this. So we build corpora. And the way that it works, no matter what discourse annotation framework you're using, is pretty much something like this. First, you segment your data, because you need to have these units that are going to have the relations to each other. And we call these things elementary discourse units, or EDUs. It's kind of a common term for those. The second step is to establish the connections between them, build the graph. And of course, then you want to label these connections and say, not only is that the thing being commented on, but the type of comment is some sort of label. And as you mentioned, one of the main frameworks is the Penn Discourse Tree Bank, but there are a bunch of these. I think the three main ones that have been implemented extensively in corpus data are the PDTB for English, which is the largest corpus available, which is a kind of partial parse. So you don't have relations for every single sentence, and you don't have a fully structured graph for the document, but a lot of sentence pairs or clause pairs do have a relation between them. The opposite extreme is probably SDRT, which allows you to have a complete DAG, because in SDRT, segmented discourse representation theory, units can have multiple relations, and in fact, the same pair of units can have multiple relations at the same time. So you get a very complex graph. And probably one that's between the two of them in terms of complexity, and is also the oldest one, is rhetorical structure theory, which limits the annotation graph to being exactly a tree over the entire document. Okay, so every single unit has a relation, and everything constructs one single tree. I'm happy to talk about the other ones later, but I'll mainly focus on RST in the interest of time. If you know constituent syntax trees, then it'll be very easy to understand how RST works because it's basically the same. There are heads and expansions. So in an NP like the mouse is the head because it's a kind of mouse. And then you have all sorts of expansions like maybe adjectives and other things. Similarly, in an RST tree, if I tell you something like unit 38 over there, use a funnel, then the main thing is use a funnel. That's what I want to say. On top of that, I might give you the purpose of that to make everything safe and easy. But if you only gave me one out of the two to express myself, I would pick 38. I would say use a funnel, and then I'd get into why do you need to use the funnel. But it doesn't make sense to use 39 without 38. So this is the head and this is the expansion. In RST trees, the leaves are EDUs, just like in syntax trees, the leaves are words. So if they're elementary, they cannot be segmented further. But you also have non-terminal elements. For example, you could group 38 and 39 together here, and then say that that as a whole has some sort of relation to something else. It's like phrase boundaries. And finally, we label the relations with discourse functions, just like in a syntax tree, you might want to label that this is the subject of a sentence. So that's what it's doing there. That's its function. Right? Does that make sense?
Should we think of EDUs as clauses?
So usually you use clauses. There are all sorts of different guidelines. For example, do you want to have cause PPs, like I did it for John? If you start admitting these, then you have problems, because then in a ditransitive, you could argue that a single word embedded in the middle of things is cause or benefactive or whatever. So it's kind of murky. The transition to semantic role labeling can be a bit murky. But clauses definitely. Virtually everybody does clauses. Hmm? That would depend on the specific corpus annotation guidelines. Some corpora include prepositional phrases, and usually they will then limit the annotation to a specific closed list of prepositions, for example, because they're interested in cause relations. It's a slippery slope. Once you start admitting PPs, most of the data that I will work with today does not have prepositional phrases, but there have been corpora that have had them. And then the question is what to include. Okay, let's see if this concept makes sense to everybody. Let's do a little test. Here's a couple of clauses. Owing to its history, Łódź is a city in Poland, has an impressive collection of residential, commercial, and industrial 19th century architecture. Which one is more important? Which one is the nucleus, as we say in RST, and which one is the satellite? What's the head of this? 6, right? I should take a vote, but I think it's pretty easy to agree. What would you call this if I gave you these 4 options? Is it a cause relation, a purpose relation, elaboration, or a concession? Just by the normal garden variety meaning of those words. I'm not getting into definitions right now. It's an elaboration. So 6 is the main one, and I'm elaborating about the fact that Łódź has an impressive collection of residential, commercial, and architecture. I'm elaborating that is owing to its history. I probably pick a different one. Yeah? Cause, right? From these 4, I would prefer cause, and most people do. I'll do a vote on the next one. Okay, so it's easy to agree that 6 is more important. Maybe it's a bit more difficult to agree on what the label is. Let's do another one. Łódź today may not have the glitz and glamour of its heyday. However, there is a certain amount of charm to its partially renovated facades and leitmotifs. Which one is more important? Who's for 51 being more important? Who's for 52 being more important? Okay, that's pretty strong evidence. And what would you call the relationship out of these 4? So wait, I need to do this through. Who's for cause? Nobody. Who's for purpose? Nobody. Who's for elaboration? 2. Who's for concession? Everybody else. So this is not a made-up category. That's what I'm getting at. Okay, so people can agree on this, and I'm not saying that inter-annotator agreement is perfect for discourse relations, but these are garden variety kind of natural language sentences from a corpus, and people have some measure of agreement on what the relations are, which is good to know. Question?
If however were replaced by the other head, it would I'd have more trouble figuring out which was the head.
So,
nucleus, is that right?
So yeah, nucleus and RST is like head. Yeah, that's exactly it though. You want to first annotate data and then go back and say, how was concession marked? Is concession ever marked by, on the other hand? Maybe it is, maybe it isn't. Right? And certainly there...
So sometimes people have...
there are disagreements. Absolutely.
This might also happen with just ordinary conjunction or something.
Absolutely. So people have disagreements, and it's interesting to study those, studying annotated data. I'll talk a little about. Okay, I'm gonna skip these.
There's no way to mark that kind of annotator uncertainty.
Oh, there is. There has been extensive work, especially by Manfred Stede, about ambiguous RST annotation and annotating disagreements. Yeah.
In this case, I'm not even sure it's ambiguity. I feel like there's a third category where neither one is a head.
So I guess there are basically 3 types of ambiguity that you could have. One of them is a true kind of ambiguity in the sense that there are 2 distinct senses, and the writer could have intended 1 or they could have intended 2. Another one is under specification. You might have like a set of relations which are very similar, and you can say, I know it's kind of contrastive, but there are these specific subtypes of contrast, and I don't know which one they are. And another one is just being the vagueness of not being certain that the directionality and the relation even exists between these 2 things. So then you could have structural ambiguity. Mm-hmm.
How often do you see true parallelism where you have essentially you're discussing Boston and in London, and you're discussing their development almost disjointly, but they're progressing along a similar discourse trajectory of,
Right.
of history, economics.
Are you referring to the fact that you might not one of them might not be more important than the other, so the nuclearity issue, or are you referring to the fact that you might have the same structure twice in the same document?
I'm thinking more where these dependencies essentially cross, where you
Crossing.
Elaborations and clauses that are cross-serially.
Right. So non-projective trees in RST are in principle allowed. They are fairly rare in practice. Some annotation schemes forbid them as a principle because they care about parsing them later with shift reduce or something. But yeah, it does happen. One of the typical culprits is kind of run-on restatement. If you go back to a point that you mentioned earlier and just state it again after having digressed to something else. Some people claim it's a sign of incoherence. So there are kind of, from an NLG perspective, but also from a kind of rhetorical analysis perspective, you might say that a text that has a lot of crossing dependencies is a text that's difficult to understand. So yeah, and people have done RST even on things like difficult text types, law or poetry or stuff like that, and then things get much worse. Okay, so let me kind of show you where the big picture is going with this. Why do you want this, and what does it look like when you have a bigger fragment? So this is actually, in fact, a fragment beginning at the second clause of something and going on only up to its sixth. And what's nice about RST being hierarchical is that you can apply it at a micro or macro level. And it has all sorts of applications that I won't talk about in detail, but can be interesting. So, for example, this is the main clause of this fragment, and you can tell because everything is pointing at it. Right? This is the trunk. So the main point of this text is we shouldn't embrace every popular issue that comes along. That's the main message here. But it begins, tempting as it may be. Right? You could drop this, it's not important. But it's a kind of concession. Right? So first of all, the hierarchical nature of the formalism allows you to get the most important unit for, say, summarization in applications like that. But you also get a lot of specific relations that you might be interested in, such as what is some evidence that this is true? Well, let's look at evidence relations. Right? You can use that for IR, information extraction. And it's also been used for NLG, which was one of the original motivators for RST, actually, because you can have a kind of discourse plan. So, for example, if you want to know how to make an argument, maybe first you should concede something that's the opposite of your opinion, then you should state your opinion, then you should give some evidence that your opinion is correct. That's a good way of building an argument. So if you're building a larger discourse, you might want to first have a plan that's based on a skeleton like this, and then lexicalize or verbalize individual units using some model that's specific to those points. Okay, if you're interested in this, I encourage you to go to the RST website, get some resources and read up on it. It's an interesting framework. But what I want to talk about today is how we identify these relations. I'll talk a lot about how humans identify these, but I'll also talk about how that differs from how NLP algorithms might identify relations. And I'll talk about how much of this information is explicit in the sense of being attached to some specific tokens in the text. And I'll kind of start from what I think is a somewhat naive approach, which is that we can just let some machine learning algorithms loose on a text, and they'll learn what's important. And then I'll try to focus on what they still don't learn and how we might be able to address that by adding some specific analyses to that. And for all of this, we'll need data. So the biggest data source that you can get for English, or in fact for any language in RST, is the RST Discourse Tree Bank. It's around 180,000 tokens of Wall Street Journal data. And because it is the Wall Street Journal corpus, you get gold part of speech and syntax tree for free. There's also a section of it that overlaps with the Ontonotes corpus, about 60% of the corpus, for which you get named entity recognition, but obviously only for named entities. This will become important in a moment. And partial coreference annotation. So you can get pronoun resolution, and definites that have antecedents get an annotation. So this corpus is interesting, but it's all Wall Street Journal. And there's another corpus that I'll be using specifically for two reasons. One is that it has more genres, and two is that it has a lot of annotations. And this is a corpus that we built partly for this research at Georgetown University. And it's a class-sourced corpus. What that means is that it's constructed by students in classroom teaching. And the concept of this corpus is that we have a course, which is our intro to computational corpus linguistics. And in this course, students begin the semester by choosing a text, and then they annotate the text. And we learn about pos tagging, and they pos tag their text. And we learn about dependency parsing, and then they dependency parse their text. We do kind of structural analysis of the document using TI-XML for things like paragraphs and headings and graphical layout, information structural annotations, named and non-named entities, coreference resolution, and the RST parses, which are going to be important for this talk. And it comes in 8 genres, which are these. We just added 4 new genres this semester. Academic, biographies, fiction, and Reddit forum discussions are also new. And these join the interviews, news texts, travel guides, and how-to guides that we already had. So right now it's a total of 85,000 tokens annotated for all of these layers of information. And if you're interested in the data set, you can have it. It's freely available, and it's on GitHub.
Is this going to grow as you continue to turn this class?
It has been every year. So this is year 4, and we collect 20-some thousand tokens every year.
Thinking about doing a MOOC?
I don't know if that would work. Yeah, that'd be challenging.
You got to maintain quality. But you can do redundant annotation.
It would be nice to grow the data set. It's not really where Georgetown is currently going with its concept, but it is difficult to teach these things. So you need a lot of attention, a lot of time with students. I don't know if this would work in a large classroom because teaching RST parsing and syntax, these are the typical categories that are difficult to do with something like Mechanical Turk, right? But I'm happy to talk about crowdsourcing if people are interested later. It's an interesting question how to do this kind of data. Okay, but that brings me to actually starting to look at questions and answering them with data. So I'll talk about relation signaling. And the question is, how do we signal relations? There's been a ton of work on this. The most obvious way is using the so-called discourse markers. So things like however, and but, and if. So if you want to signal a conditional, you use the word if, and everybody knows what you're talking about. Sometimes it's a bit more subtle than that. People use adverbials, especially sentence or stance adverbials, things like clearly, supposedly, or even multi-word expressions like in reality. Right? That can be taken literally, but it could just be a contrasting to a hypothetical. And then, surprisingly, content words, especially if you're doing automatic classification of relations, then it wouldn't be surprising to learn that the word good is a good signal of an evaluation. Right? That's kind of sentiment analysis 101. But it's not clear that this content word is as such a signal of the relation so much as it is just the content of the evaluation. Right? Still, it's a sort of overt signal, and the same applies to multi-word constructions, expressions. Things like last year are a very good marker of temporal modifications where you elaborate on when something happened, for example. But of course, they just literally mean last year. Another interesting thing about the way that such resources as discourse annotated corpus are created is that annotators are told to use these kinds of words as diagnostics. So if you look at, say, the guidelines for PDTB, for an implicit cause relation, you ask yourself, can I connect these two things with the word because? So these are quite central to the definition of relations. And then once you have a corpus annotated for this stuff, what people usually do for signal detection, or the first thing people do when you have a new discourse annotated corpus, is do a cross-tabulation of frequency of each word and the relations that it appears in. Right, so this is from a paper on the newly minted Russian RST corpus from last year. First thing you do, and this makes complete sense, is to look at the words. And then you discover that the most indicative word of an elaboration in Russian is katori because it's the relative pronoun. So which, right? So the thing, which, blah, blah, blah. So if the guidelines say that these kind of relative clauses are by default elaborations, which makes sense, then of course the word which is a good indication of that. But there are some issues with this. One of them is frequency thresholds. So from what frequency do I say that it's a signal? And another one is specificity. So of course you could use PMI or you could use some other metric, but some words are not very specific. For example, the word and is guaranteed to appear in absolutely every relation in the corpus. But sometimes it's just coordinating two nouns, right? That doesn't mean anything. So how do you know that it's being a signal for something like a list of things, or I don't know. We have and here somewhere. So yeah, joint, and as well, i takже, right? So that's a good question. How do you know that? Because the word and also appears in a bunch of other relations. And another problem is limiting the context, is saying, okay, this word I will only count if it's in the context of some other words. So multi-word expressions and position in the sentence. And so NLP work on automatically inferring discourse relations has basically said, okay, well, this is the data that we've got to work with, and we're going to project it into some space where it's better for us. And I like this quote from Gene Eisenstein, which is still the state of the art for RST parsing for English. The core idea of our work is to learn a transformation from a bag of words surface representation into a latent space in which discourse relations are easily identifiable. So the data has to be in the words. So the information is in the words, and we'll just project them into some space in which we can discern them better, and this is the state of the art. And I think this is echoed in much NLP in recent years, more so recently with RNNs, which is why I started my talk with that question. The expectation is that you can get from text to labels. Why wouldn't you be able to do that? Humans get the relations by reading the text, right? But really, we all know that it's not text to labels, it's text to embeddings. And with trainable embeddings, it's text embeddings to labels to back to embeddings. Right? So you infer the optimal embeddings for your task. And this has been Browd et al.'s excellent work on cross-lingual, multilingual RST parsing. So let's do that. Relation classification with RNNs. Very reasonably, if you use an encoder architecture, let the RNN run on some words, feed it some embeddings, it will give you a distribution over possible relation values. Right? So let's say if you're reading the words "if we were fish," then you look at the softmax probability of the relations and you discover that condition is the most likely one. It's perfectly reasonable. The question is, how do I get signal information out of this? How do I know which words are signals of the condition relation? How does this improve my situation? Yeah?
Do you run this on the nucleus or the satellite?
You could do either or both, with a separator between them, without a separator between them. That gets into implementation details. So yeah, you could. Keep in mind, though, that if you're doing parsing, then you don't necessarily have the ground truth for which is the parent of the relation. So that's kind of a question. If you give it gold annotation. And then there's another question of hierarchy. If you give the system access to the nucleus and satellite structure, do you give it the immediate constituent, the head of that 2 units, or do you give it somehow the entire span of text? If your connection is at the level of the relation that connects 2 paragraphs, that quickly becomes unfeasible for RNNs because you're looking at a huge batch of text. So, yeah, there are some things to consider. But I mean, more generally, how would you know? And the answer that I'm alluding to is much, much simpler, is you can simply ask the network where the signals are by polling it at every time step. Right? So you could just ask it, were you certain here? And I'm guessing in this example, the network had it at if, right? There's no way that it didn't already have a very strong inclination to guess condition when it saw the if. And of course, you still define your loss based on the EDU relation for the entire unit, but you can check the softmax at every step. So I tried doing this with a BiLSTM. I gave it word embeddings and I gave it character embeddings. And the first thing I noticed is that it oscillates. So of course, it's trying to maximize its prediction accuracy token-wise, and then you end up having these oscillations like, okay, it knew that it was a conditional at the if, but then it changed its mind to a cause relation, and then changed its mind back to a conditional, because it doesn't understand that it needs to predict one thing. Yeah?
So are you saying that you trained this BiLSTM only on the final output? And then
Final output?
So in the previous slide, you had this sequence.
That was an encoder architecture, but this is token-wise. So I'm telling it at every token what the correct relation is.
So at training time, you're passing signal there.
Yeah.
At every token. Okay.
So what I then changed up with is I tried using the kind of sequence classification BiLSTM CRF architecture that's become popular for things like NER. And this kind of solves the problem because the network learns that it needs to have a plausible path through the hidden categories. And then it still outputs different probabilities at every word, and it's still primarily convinced by the if, but the sum total of what it does has to result in a plausible pathway. So it needs to choose, effectively. Okay? So that's the basic idea for this kind of more naive text-based model. I think it's not so interesting to look at what the prediction accuracy is because this is not a realistic scenario of how to do discourse parsing, right? You're not supposed to just look at the text. You're supposed to look at the structure and make kind of, I guess the standard is to make shift-reduce decisions. But still, it's not bad. You get an F1 score of 41% on 60 relations. The reason is that some RST relations in the RST discourse tree bank are very small. And the majority baseline is actually 33% for elaboration. So that's not that impressive. It's a relatively easy task on the Wall Street Journal data. You can compare that to state-of-the-art results, which are much better, but they're very different because they use the collapse set. They do it EDU-wise. They're using 18 relations, and they're doing it in the context of full discourse parsing. So my point is not necessarily what the accuracy of this is. My point is going to be more how much this will or won't improve when you give it other categories. Yeah?
This finally brings the question out of my mind. Because when you were giving examples, you wanted to reduce the relations to a small number of categories. And it wasn't clear to me that the relations are categorical in the first place. So this tells me that you have 60 types of relations, which means it's hard to put them in a few categories.
It really depends on the corpus and whether or not you collapse certain things. So the full RSTDT corpus has a maximum of 78 relations from its original version, depending on whether you include or don't include I kind of skipped over this, but there's such a thing as multinuclear relations where there is no head. So this is a bit like coordination in syntax. Right, and then there are kind of hierarchical clusters. So people will do, in RSTDT, you have volitional cause and non-volitional cause, for example. So a pretty sensible distinction, right? But you can collapse them into cause. And virtually all work on discourse parsing, including these papers, uses the maximally collapsed set where there's just one kind of cause and so on.
And do you have a sense of what kind of agreement you get between regulars on these tail categories and whether you can increase that agreement by?
Yeah, there's literally a ton of work on that. And it varies by corpus, it varies by genre, it varies by everything that you want. But the one piece of common wisdom is that if you have a large inventory, you should make it hierarchical exactly so that you can collapse. Right, and that's the same is true for the Penn Discourse tree bank. Okay, so what do I do with this now? Right, this is kind of an interesting exercise. It's an NLP system that's not that useful because you could do better. What I'm actually interested in is what is the token-wise softmax at every time step. That's what I actually want to get at. And what I'm going to show you next is a visualization using shading based on 50% softmax probability within the sentence out of the maximum attained in the sentence. So if some word in the sentence has a 60% probability of being an elaboration, then 50% darkness of every word in that sentence will be how close it got to that word's accuracy, or to that word's probability. The other 50% of its shadedness will come from how good it is within the context of the document. So out of the maximum softmax achieved by any token for the document. The result of this is that 50% of my darkness for every word is how good I am in my sentence, 50% is how good I am in the document. And this has the effect that sentences where no word is a good predictor are kind of bleached in the visualization. Sentences that are good are darker, and irrespective of that, still every word that is better than its neighbors is darker in that sentence. So it looks like this. The first clause you have here is this occurs for two reasons. This is actually data from GUM, not from RSTDT. This occurs for two reasons. This is labeled as a preparation. And the reason is that I'm not actually telling you the two reasons. I'm preparing you. I'm about to tell you two reasons. I haven't actually told you the reasons yet. And good indicators of that turn out to be the word this capitalized and a colon. Seems pretty reasonable. And that sentence has good signals, which are relatively dark. This cause sentence afterwards doesn't have any good signals, and it's kind of bleached out. There wasn't a particularly convincing word for that later. And you can see that it kind of learns all sorts of interesting patterns in the data. For example, I like this one, which is a concession. You should use a ceramic bowl, blah, blah, blah. But plastic works too. And the way that the network highlights this is, but, too. I don't really care what's in the middle. I care about the but and the too. Right? And the interesting thing about this is that the word too by itself might not necessarily have been a good signal of a concession, but it's a good signal in the context of a sentence that also has the initial but. Right? If that makes sense. So the next question I ask myself is, how ambiguous are these signals? Right? This is just for the explicit signals that the network can identify. And I started looking at the softmax of each word form across the entire data set, and how reliable the network found each word on average. So you can see that there are some words that are very reliable, like this capitalized if here. And remember, I have a character LSTM as well. The capitalized if is always a very reliable signal of its relation because it's a condition. The lowercase if is sometimes a good indicator, but it has a much wider spread. The reason being that sometimes it occurs in embedded speech. So I asked John if he's going is not a conditional. It's considered something else in the analysis scheme. So the network picks up on sometimes this seems to mean something, but not always. Other ones are like and. And is usually a meaningless word, but there are a ton of outliers. Right? There are these particular ands that are important. And you can inspect what the network is doing by looking at high scoring and low scoring ands. Here are some low scoring ands. But will continue as a director and chairman of the executive committee. That's coordinating two nouns. Nobody cares about that and. That doesn't mean anything. Or even sentence initial and. And one began trading on the NASDAQ last week. This is RSTDT, so Wall Street Journal. The and wasn't helping. Almost all important ands are unit initial. So you'll get things like and is involved in claims adjustments for insurance companies. Right? You can tell that it's kind of continuing something just by looking at it. And this is the list relation in RSTDT. Distinguishing it from the elaboration relation, by the way, is non-trivial. And guessing this is always a pretty fair bet because it's the majority baseline. But you get it even, so this one is actually separated from the beginning with this dash. And it still notices that it's better than its neighbors. Okay, so this is kind of how this visualization works, but it's not an evaluation. How do I know which one of these, maybe I can convince you intuitively that these are good signals, but do I have a gold standard for this? And I don't quite, but there is something interesting to compare this to, which is a corpus that Maite Taboada and Debopam Das did in 2013 called the RST Signaling Corpus. And this is a very, very interesting data source. It's basically RSTDT, and they sat down and re-annotated it in the following way. They said, given the relations as they were annotated in RSTDT, tell us what was the signal, how you knew that this is the relation. So an annotator is basically given the RST analysis, they're told this is a cause, now tell me how you know. Find any signal that this is actually a cause. And they used both explicit markers, like discourse markers and kind of overt expressions, but they were allowed to use a bunch of other categories. It was very open-ended. So they developed a scheme by basically asking themselves, how would a human know this? Give me any reason. So they have syntactic devices, cohesion devices like coreference and pronouns, but also genre conventions, graphical layout, anything was fair game. You could say any reason that you want. The one problem with this corpus, which you can get from LDC if you're interested in, is that it was annotated using a tool called UAM Corpus Annotation Tool, and that the annotations were placed, this is kind of funny, they were actually done on top of the annotated Lisp format files by labeling the relation label position in the document with the signaling information. So here's an example. Spencer J. Folk, President and Chief Operating Officer of something, was elected a director. Second sentence, Mr. Folk, 55 years old, succeeds Duncan Dwight. Anybody who's ever read Wall Street Journal corpus material knows this kind of language, right? Look familiar? And the signal is marked as lexical chain. So single signal, semantic, lexical chain. What does that mean? It means that you can notice that this is an elaboration because there's a repetition here. Spencer J. Folk, Mr. Folk. So the intended reading of the signal is the repetition of the word folk is a lexical chain which signals the fact that this is an elaboration. The problem with this annotated format is that there's no way to get from this annotation to where's the location of that word. Right? Unless you're a human, in which case this makes sense to you. So I tried doing a little toy evaluation. I reread 3 documents looking at 210 RST nodes for 153 signal annotations, and I tried to figure out what was the token that they were intending by this. And to my surprise, only about half of the cases had a token that you could anchor it to. Okay, so this is quite a low proportion. I was expecting, I would be able to say some token that has something to do with the relation relatively often. But it turns out that very many cases are attributable either to genre conventions or, say, a zero relative. What do I mean by that? For example, in a remark, someone should remember this time next year. This is labeled as a signal, zero relative. So normally you'd have that someone should remember this time next year, right? And that word would have been the signal, just like the Russian relative pronoun. But the word is missing. So the signal is zero. The signal is not present. Or graphical layout, right? So how do I know that this is? Because it's the heading. The heading just consists of words. You don't know that there's no token that you can make responsible for that, right? So there were those, and then about half of those, again, were cases that I don't think are reasonably detectable by my RNN. Because the lexical chain case, and this got me thinking, what are the limitations of this text-based RNN? If you have Senator Byrd is chairman. At best, an RNN can learn that the word bird with a Y is a great indication of an elaboration. It can learn that. It can modify the embeddings for capitalized bird. It can do all sorts of things. It can never, ever, ever learn, based on the current architecture, that this proper noun is important if there's an identical proper noun in the preceding sentence, no matter what that proper noun is. That is something that the word embeddings will never, ever learn. It's not in their capacity to learn that. Okay, they can learn 10 different examples of names that are indicative, but they can't learn that any name being re-mentioned is important. So to evaluate this, I use recall at K. I'm sorry, yeah?
There's a lot of discourse relations that are implicit, right? Is it possible to incorporate that into your algorithm as well?
That's the million-dollar question. That is exactly the question. How can you incorporate them? How can you get at this information? And what I find interesting to do is to ask humans, how did you know? And then see, is my network in a position to figure this out? Do I have that information? If it's a word, if it's based on the presence of a word form, even in the intricate presence of neighboring words and this but blah, 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 to, that's stuff that RNNs are great for. They can figure out the exact relevant ands from the non-relevant ands based on position, neighboring words, and so on. But some sources of information are simply missing, and these are they. So if you look at all of the ones where I could even figure out a token, including Senator Byrd, recall at 1, meaning if there is any signal in the sentence, did the network choose that exact word as the best word in the sentence? That's recall at 1, and I get about 30%. Chance is like 15, I don't know. Recall at 2 means if the sentence has one signal, is one of the top 2 words ranked by the network that signal? If the sentence has 2 signals, then full points are given if the 2 top words are these 2 top words, and 50% points are given if it got one of the 2 words as one of the first 2 top words, and so on. And you can get, 30, 50-something, 70-something. That's not bad, and it's much better than chance. If you only give the network the ones that it can reasonably know without Senator Byrd, then it suddenly becomes quite good. So 40% for recall at 1 I find quite respectable. 70, 80-something. Gets much better. But it's still missing a lot of stuff. Right? All right, this brings me to the last part of my talk, which is what happens when you add stuff. How can we start giving it the information that it needs in order to find these additional signals? And remember, it's not trained on signal detection. I didn't give it gold information, this is a signal. I only gave it the relations. It figured out what the signals were by itself. Okay? This is not supervised learning. Well, it's supervised by another category. So how can we get at these unresolvable cases, like lexical entity coreference, for example? Or other things, pronouns, right? Whenever there's an it or a they, depending on what that stands for, that could have been a word that word embeddings could have helped me with, but instead I got an it. Right? All I got was a scrummy pronoun. Or say restatements. This is one of my favorite ones. To recognize a restatement, this is what we call a multinuclear relation, where both parts are equally important. The single most costly thing we spend on is rent and advertising. Those 2 together make up the bulk of what we spend. That's exactly the same twice. And if you realize that the word spend is repeated, that's relevant to identifying that it's a restatement. But remember, a sentence-wise RNN that's just reading the sentences can only learn that the word spend seems to be an indication of a restatement. It doesn't do this, basically. And other things that are non-token signals. So the clause types, like an adverbial clause or a zero relative. Other things that are meaningfully absent that the network should have learned. Oh, but that's not here. Is that a type that I can recognize? Genre. Some of you might think genre is already inside the text. Of course you can recognize genre from text. Why would I need to encode that explicitly? Well, if the RNN is reading sentence-wise, keep in mind that it might not have enough to infer the genre. You could very easily do genre with naive Bayes on the entire text, but that's not what you're doing here. You're expecting it to infer genre from a very tiny text snippet. You could actually have the exact same sentence verbatim with a different relation, which would be, as a prior, predictable from the genre. And graphical layout, which is totally absent. So what I did is pretty simple. I just concatenated some vectors. I just concatenated some annotations. Let's say I give you dense embeddings to stand in for some entry bank tags or something. And see how well it does. So this is now on GUM, which is substantially harder than RSTDT because the baseline is 25%. And this is what the text-based RNN gets, which is 10 points above baseline, which is great. Remember, so for GUM, this is 21-way classification, an F-score for multinomial classification. Adding genre is not super helpful, but it helps a bit. And you might wonder why. Why does it add an F-score point? So if you think about it, genres are quite different in how they express these different kinds of relations. Like, can you guess which of these 8 genres this evaluation is? This is an entire statement. The entire EDU is this negative smiley. Is it academic? No. Okay, so I think everybody knows it's Reddit, right? So you can know that. But that's not necessary for my model because actually it can learn the embeddings for a smiley. It can even learn the character embeddings for smiley constituents, like whatever nose shapes they have, like an initial colon character embedding and a final smile-like. But what it can't learn is the priors on relation types by genre. So for example, the relation solutionhood, which is used for question and answer pairs, trivially is most used in interviews because there are questions. That's not really necessary. You could have gotten that out of question marks and WH words. But some of these are very non-trivial. So for example, concession, right? You might be surprised by this, but concessions are most frequent in travel guides. Why? Because you might say, well, you should go to the British Museum, but actually there's also this other museum that's great, and other things. News doesn't really concede an alternative narrative very often. It says one thing, and it does not constantly concede that it might be wrong. That's not something that happens in news so much. And a lot of these are very skewed. How often do you get a conditional? In how-to guides, you get a lot of conditions. Right? In other genres, you don't get a lot of conditionals. Contrasts and so on. So those priors matter. And if you then inspect what the network learned when you give it a genre, you see that it starts highlighting different tokens. So this is an example from a how-to guide, which is a recipe. Some of them are recipes, but often they'll have a list of things you need, right? Like ingredients, tools, something like that. And you can kind of also see the graphics here. I'll get to the graphics in a moment. But what it learns is if you tell it that this is WikiHow, which is where this how-to guides come from, this is how to make vegan cupcakes, then suddenly it flags this number here. Why? Because numbers in general are quite common. They don't usually signal anything about the relation. But a unit initial number in the how-to guide genre is very indicative of the list of ingredients, which gets flagged as joint. That's just saying a list of things, right? So suddenly it learns, oh yeah, I know from this genre that numbers are suddenly important. It allows it to give it a different intercept for these, basically. Or you might even learn something about content words. So travel guides often use words, either the word local or possibly other words with similar embeddings, and that ends up being an elaboration. So it learns that for that particular word at random. Or it might learn the baseline probability of all sorts of ambiguities like, which can be a preposition, but can also be an evaluation verb, I like it. Right? It's kind of ambiguous. This is from fiction. Next up, I have some more form-related factors. Is it worth giving your network pos tags and syntactic functions from dependency trees, or even just sentence types? So sentence types are things like imperative, declarative, hypothetical, all sorts of kind of basic sentence types. And you might think you can tell immediately. You can't always. Even if you have pos tags, an infinitive and an imperative are both tagged VB. They look very similar, right? Mm-hmm. Oh yeah, so these are individual, this is like individual features, and at the end I'll have all of them together. This is, I only give it a sentence type and text, I only give it grammatical function and text, I only give it pos tag and text. Hmm?
How meticulous were you in determining the embedding size for each of these things?
So I kept the embedding size constant, and then I tried adding square root of number of categories for the dense embeddings for every category, and then I tried either handing text that as an extra buffer to grow or not. And that's where you get these numbers. So basically not is better, actually. But I have to admit, also in terms of how state-of-the-art this prediction accuracy is, I did not hyperparameter optimize this at all, and I was probably didn't do a lot of due diligence, and I could have gotten this to be better, probably. So pos and dependency function. Why does that matter? Well, you know, the word meaning, for example, if it's gerund, then it's an indication of an elaboration. Meaning that you should use it as a first strike weapon or something like that. But there's no that here, so actually it's quite difficult to notice by context which kind of meaning this is. The word meaning is self-contained within the text as a noun and does not indicate an elaboration at all. Even the character LSTM, which might have noticed ing here, is not going to help you with that. Or grammatical functions. So this is the biography of Emperor Joshua Norton. Does anybody know who that is? Oh, a couple of people. So it's this really strange story about this guy in the 19th century who decided that he was emperor of the United States. If you want, it's very entertaining. You can read about him in Wikipedia. It's one of the biographies. So he reemerged in September 1859, laying claim to the position of emperor of the United States. And you get, once you know that this is an adverb clause modifier, suddenly it likes that better for this, what's this sequence relation in this case. Okay, so that's kind of adding an ing adverbial. But, you know, it could have been just a noun ending in ing, right? It might not have known this particular word from the training data. And almost last, I tried entity and coreference annotation. So for this corpus, we have complete entity annotation, including non-named entities and singletons. So if there's a reporter, that's a person. And also for pronouns. There's actually a well-known relationship between referential accessibility and RST graphs. There's this work on what's called Bain's theory in the late 90s, where people hypothesized that you can only use pronouns to refer back to things that are in a certain relationship in the RST graph with where you are right now. And actually, I had a paper about this at the RST workshop at INLG last year, where I tried to do heat maps. So if you say, I'm interested in predicting where are antecedents to things in this unit here. The blue one is the target unit. And then you can actually build a heat map of where some antecedents might be likely without looking at the text. So the algorithm only has the RST tree at its disposal, it doesn't actually get to look at the words. So it might infer that if I'm part of a sequence, then all my neighbors preceding me might have the same pronoun. But this guy's an elaboration of one of these guys, so it's indirect. Maybe here I won't have one of these. This is a bit further back. Maybe evidence is a good relation to still be in the loop. Maybe this one isn't. Right? So stuff like that. And of course, the priors are different. This is not surprising if you think about the syntax of English, but say purpose clauses are much less likely to be coreferent because, first of all, they're usually two infinitives without a subject to keep everything safe and easy. Second of all, thematically, you don't usually mention the same thing from the thing that this is the purpose of again in the purpose clause. Right? So very often you'll say A for the purpose of B, and B will not contain the same entities as an A because you're telling about other things why you do this. So you see that the coreference likelihood drops substantially. So just by knowing priors for how likely it is to have coreferring entities. And you can give it, so the things I tried giving it is the entities and whether or not this was mentioned, the same mention. So this is for the senator bird cases. And of course, now the network also knows about entity types for pronouns. So they in English can be anything, as opposed to it, she, and he, but they does not distinguish even living from non-living. So it can be quite helpful. And finally, and this is, I don't know, for linguists this might be disappointing or this might be totally obvious, but layout is tied with coref for the most helpful. And this is information that's entirely absent from plain text. So unless you want to throw, I guess, HTML at the LSTM and see like whether it figures out paragraphs and things, having these kinds of closed class annotations, just paragraphs, headings, the things that our annotation scheme contains, captions. This is stuff that we have in TI-XML for the corpus. So we have images, the position of images and captions, ordered and unordered lists, beginning and end of list items, all sorts of things like that. And they end up being quite helpful, which is totally not surprising if you think about it. But you can also inspect and see what it does. So it suddenly gets, oh, wait, this is the beginning of a new bullet point. Right? So it just kind of triggers, oh, wait, this is important for this being something. Preparation is a typical relation for the beginning of sections. Or for kind of very short paragraphs, it gets like, oh, beginning of a new paragraph here, this might be a joint, a list of things in the bullet points. So the network can learn from that. If you combine everything at once, then you will get a boost of, what's this, a 7.5 F-score points over text, and I'm sorry, I'm getting tired here, 18 points over baseline. Right? So this is basically just by giving it all of these predictors at once. And of course, it learns to toss out what it doesn't like, and it will learn useful feature conjunctions because it's smart. Right? So I guess what I'm trying to say by this is that there's no reason not to give categorical annotations to RNNs, and they'll, if they're really useless, they're going to get thrown out at some point. But it's pretty reasonable to believe that the network can divine this, right? Even from the earliest work on coherence and text tiling, Hurst's work on text tiling used paragraphs as a pretty reliable indicator of text structure. Why wouldn't you want to have paragraphs in? It's going to need to resist the temptation to just throw text at things. So I think maybe we can't get everything from text, or even if we could, maybe we shouldn't want to. It's possible that it would be more efficient or easier if we included other predictors. And an important source of evidence for this is to just look what humans do. Humans don't only use text. It turns out that half of the things that people say in this RST Signaling Corpus were things that you couldn't pin on one token. That's an interesting thing to notice. And even if you could somehow pin them on the text, like the senator bird case, remember that text and embeddings are not the same. There are all sorts of aspects of text that are not encodable in the way that we use embeddings kind of as a garden variety. I'll just throw this through my RNN. And sometimes the text can actually be identical. You can get, the most extreme cases are short sentences. You can have a sentence that's literally the word yes, period. Right? That means to get a relation. And of course it has 5 different relations in the corpus because the sentence is common. But the priors on what that relation will be are totally different based on genre, based on how far into the text you are, based on all sorts of other features which are not just the text of that sentence. So that's important to look at. Okay, this brings me to my conclusion, which is, first of all, on an optimistic note, this is a very good time to be working on discourse. Both in terms of the data that's available to us and the learning approaches that are available to us. It's an exciting time. And if you consider everything that you can know about a text, you'll discover all sorts of interesting interdependencies, some of which will only become clear once you inspect the data. And just work on visualizations and figure out what is my model actually attending to here? What does it care about? And I think it's also a time where some older ideas from computational discourse models are suddenly becoming feasible. So for example, in this idea of generating heat maps for likely locations of antecedents, it turns out that a lot of the work kind of presaging this was saying these things are important, but was using approaches that were not yet conducive enough to capturing, say, semantics in a way that's not linked to a specific word form string. And embeddings give us that. And now suddenly we're able to talk about these things in a much more useful way. That said, we still need more stuff. So we need new data, and a lot of my work, my daily work, is spent building data sets, tools to make data sets, annotation tools, NLP tools, and we need new learning approaches. And I think part of the interesting challenge is to really look at these sentences and think, wait, what is my model not getting? Why is it not getting that, and how can I change that? All right, that's all I had to say. Thanks.
So I have lots of questions. Let me get the ball rolling with one. What you're advocating in your long graph that you laid out for us is a pipeline approach. And I wonder if you've also thought about a multitask learning approach, which might have the benefit of having soft tags in effect, or representations that are getting at something underlying that helps explain all of these tags at different levels without being completely captured by those tags.
I completely agree. I think there's a ton to be said about the learning approach, and you could talk about early fusion, late fusion. You could try ensembling some of this out, blendering some of this out, and multitask learning. So what task are you thinking of as the second task?
All of the tasks that you just described. You have other systems to get them, and then you.
Oh, I see. So doing. I see.
So what if you did discourse
on
parsing
system?
With,
right.
Syntactic parsing and layout markup and whatever else it is.
That makes sense. So in terms of the accuracy that you'd get from that, you'd have to predict that it's better, because if it weren't better, it would just do what it would have done in the non-multitask context, if it's been implemented correctly. One of the challenges is the amount of data that we have, which is not terrific.
You don't have all tasks on all data.
That's true.
You can still do multitasking with only partial data.
That's true. You could do pre-training, and you can also do all sorts of autoencoder, frozen layer things where you take stuff out and learn useful features. I think that all sounds interesting.
Actually, were you advocating a pipeline approach where you actually predict those things, or were you saying when those are available? I mean, actually your experiments, were they using gold?
They're all using complete gold information. They're all gold data, which we have, and because we have it, for some of these categories, there is no good NLP. I continuously lament the state of non-named entity resolution, even for English. So to know that a reporter is a person seems trivial, but somehow everybody's just focusing on NER. And for a lot of these purposes, it totally just matters that it's a person. It doesn't matter if it's a person in the table of authorities or if it got tagged NNP by chance. For a lot of these things, there aren't NLP systems. But I absolutely agree that if one wanted to use this for actual discourse parsing, one should do that. Kevin.
So I think most ACL type works, they focus on just predicting the discourse relations and they get high accuracy. I think it's interesting you're going further in trying to find what are the discourse signals, discourse markers.
Right.
I wonder what kinds of other applications or scientific queries you think you can get from knowing what discourse signals there are.
Yeah, so first of all, as somebody working in the linguistics department, my primary responsibility is to talk about the interesting categories, and if I can predict them but I can't explain why, that is less interesting. I think there are a lot of real-world applications for this, especially in any context that involves human learners. So if you have a human in the loop that's interested in why you made that decision, this can be either for straight-up pedagogical applications where you're doing language learning and you'd like to know, like, how do I know that this sentence is so-and-so? But there are also applications in security and in medicine and in all sorts of other things, either to highlight things for analysts. Let's say you're doing phishing detection and you'd like to know, how do you know that this person is a fraud? How do you know what part of the text is the part where they want you to do something? How do you know what part of the text is the part where they're trying to convince you of their credentials? You could do all sorts of work using these kinds of relations to try to understand who you're dealing with, what is their actual vector, and then you can use that information to plan interventions and to decide on a course of action. So there are a lot of applications, actually.
And continues to bother me that how deeply you read these and how much context you have really influenced labels. Go back to that example where you spend the most on these two things and whatever.
Right.
You call them restatements of each other, if I remember right.
Right, that's what we call a multinuclear relation.
Starting from a moment that I said I spend 20% on rent and 20% on advertising and less than that on a whole bunch of other things, then the single most costly thing I spend on is rent and advertising. But together
That's right.
they don't make up the bulk of what I spend.
That's right.
And therefore this might, like, in other words, there has to be other, how deeply to read this. Like, if, for example, if it were true that they make up the bulk, then in fact it's not a restatement, it's maybe some kind of elaboration, or the other one is like, so
Right.
to me it is not obvious that you can even perform this task reasonably with local context, like one sentence or a couple of sentences, because you really are getting into this deeper interpretation, which I claim cannot be done without much broader context.
Right.
The whole document, maybe the whole universe.
Sure. So let me answer a couple of aspects of that.
Interlabeler agreement on these things.
Yeah. So let me say a couple of things about that. First of all, specifically for restatement, most RST formalisms assume two variations of it. One is multinuclear and one is satellite nucleus. So if you have what we call a partial restatement, in which I say something and then I repeat bits of it, then you would have the nucleus as the main thing and you have a partial restatement after that. So that's a thing too. Then in terms of how much context you need, the human annotator is always instructed to use whatever they've got, including reading the entire thing again from the start. So that's fine. They're allowed to reread. This isn't like self-paced reading or anything. They can go back. In terms of what the computer needs, I'm totally in agreement. So, for instance, the literature on coreference. People talk about how many sentences back is reasonable to look, or on MT. So MT, obviously everybody knows that one of the main problems right now is the kind of sentence border. How many sentences do you need to do perfect MT? That's kind of an empirical question that should be answered with annotators who say, how did you know? And if the way that they knew involves things that are very far away, you can get a distribution on how much context is relevant and try to figure out how to put that into your model. That's what interests me. What did you need to know, and how can I get that how can I model that? That's what I care about.
Maybe I should state my concern in a different way.
Yeah.
So when you take the MP example, so the resulting other language and target language sentence serves its own purpose. So whether or not it's good or bad can be evaluated in some extrinsic way, right?
Yeah.
There is no intrinsic, in other words, these are intrinsic evaluations of these stacks. And if this were embedded in some other task, like an instance task of some kind, some
right.
task, I would evaluate that. I would not worry about the labeler agreement on these things. Because in some sense, to me, this looks like an immediate task created for the sake of having a task. And that is hard, and yet can't settle down on some category of labels and
right.
force people to go with it. After all, when I read a document, I get some sense out of it. I do inference on it, and I can act on it.
Well, I'll readily admit.
If you had
yeah.
whether you have numbers about how much people agree and how much context you agree.
I do when there are. So, like, if you seem to want one number, so I'll say 80s. But there are
the hard relations.
So the thing that gets reported in the state-of-the-art discourse parsing thing papers is that the ceiling is human accuracy, and that's in the 80s. And then they always report this particular, set of studies. But it really, really matters what kind of text you're working on, what the inventory of relations is, what the definition of elementary discourse units is. So you could really play around with a lot of parameters and reach different levels of consistency. But yeah, if you want a ballpark number, it's an 80s kind of thing. And I think, here, this is me doing a concession. I'll readily admit that there are clearer cases and less clear cases. There are some relations, and especially in typical realizations with them, where people totally agree. Right? Some of the easy ones are condition, or some type of contrast. And then if you get, like, a lot of schemas have three types of contrast, restatement, concession, and antithesis. And then people start disagreeing on them, and the least clear one is maybe antithesis. So people know about this. There is literature on this. I wouldn't say that it's a task that's done just to torture students or something like that. It's not. Actually, this is potentially one of the more enjoyable tasks, actually, compared to some other things. But I think that there is some reality to it. There are a lot of questions in linguistics that you can't address without postulating discourse relations. I'll give you the most basic one. How do you know that a rhetorical question is not a question looking for an answer? What kinds of rhetorical questions are there? There are a bunch of kinds, right? There are kinds where you're trying to insult somebody by pretending that, like, isn't that obvious what you're saying? There are kinds where you're trying to ask yourself something in order to introduce it into the discourse and answer it yourself. There are different kinds, right? How can you even...
Maybe you need a more fine-grained scheme.
So for those, right? But the question is what, like, if you want to address these things, you need to have discourse relations because you can't talk about those things otherwise.
So to what extent are the relations I'm sorry, somebody else had a question.
You guys have such good questions. Go ahead, Jacob.
Actually, maybe yours has to be the last question.
Why don't we, I'll ask them.
Thanks.